Welcome to Table for 92, element number 72, hafnium. It's number 72 because it has exactly 72 protons within its nucleus. For hafnium, we're cooking up some chicken paprikash for the discoverer, Hungarian-born George de Hevesy, a brilliant scientist who had a rather eventful life. He spent a lot of his adult life doing great science while running away from the Nazis, so incredible story. So anyway, hafnium is cool. I'm really glad to be done with the lanthanide elements. I mean, they're fascinating and are so incredibly important to the modern world, but man, are they confusing. So, yay for hafnium! First off, hafnium is not found in a pure state in nature. It has no biological role in the human body and is a silvery metal, just like all the other rare earth elements. Also, hafnium isn't found in food. Again, just like all the rare earth elements. So I gotta get, creative with my food choice for these kinds of episodes. Hafnium was discovered by George de Hevesy and his assistant Dirk Koster in Copenhagen. The name hafnium derives from the Latin name for Copenhagen. It was called Hafnia. So I could have cooked something from Denmark or Copenhagen instead, or some food from Hungary, but I went with chicken paprikash. It is a fantastic meal. It comes with its own cool history and is really, really important in Hungary, where the birthplace of our discoverer is. Okay, now I also wanted to explain why the Hungarian George de Hevesy was working in Copenhagen in the first place. I really want to talk about his life because it really is extraordinary. So, George de Hevesy was born into a Jewish family in 1885 in Budapest, then part of the Austro-Hungarian Empire. He came from real privilege. Both sides of his family were like really wealthy business class, extremely wealthy. Like his family had an estate with a castle on it next door to the emperor's castle. And they would go on like hunting parties with the emperor. So like that kind of old money, pretty crazy. But yeah, as a child, George was sickly, as they would say at the time. So after he graduated, the like equivalent of high school at that time, he went to study chemistry in Freiburg, Germany, where the climate was better for his like sickliness. He was the first in his family to get into science actually, and was clearly very good at it. He ends up discovering an element, right? So, he got his PhD in 1908 and moved to Zurich, where he got work. He attended, actually, a inaugural lecture by a small-time physicist named Albert Einstein. Apparently, there was just like a few people that attended, so man, if that was me, I'd tell that story to everyone I ever met. Well, George, he moved a lot, so he really seemed to be restless and would live all over Europe during his life. He then moved to Manchester, England to work with Ernest Rutherford, who has an element named after him, Rutherfordium, then Vienna and Budapest, and he was constantly sickly. Like crossing the English Channel, he was so seasick he had to be admitted to a hospital for several weeks afterwards. And crossing the English Channel, by the way, is like an hour and a half it takes by boat, so yeah, kind of a sickly guy. The next big thing to happen to George and the world actually was the First World War. He was initially very enthusiastic about the war, as was nearly everybody, until they all found out what modern technology could actually do in a war and how horrifying it was. So anyway, George joins the army, and on his first march collapses and passes out. So the army is like, maybe you should work in an X-ray unit in a hospital. I hate to put the stereotype of like the science nerd who's bad at sports here, but he does do that. So, World War I ends, the Austro-Hungarians lose, and the empire is split into Austria, Hungary, Czechoslovakia, and Yugoslavia. This really sucked for George because it made travel a lot more difficult. There were closed borders and political turmoil. Like in Hungary, the communists took over and declared a Soviet republic. This would have been very distressing for George. If you know anything about communists, they aren't big fans of people who own castles and hang out with emperors. The Soviet republic doesn't last long though. There was basically a civil war until the Romanians invaded, and then a former naval admiral came in and said he was king now. Some people call him a fascist, and he certainly acted like one. Anti-Semitism in Hungary was worse than it had ever been before. So George moved out of there and moved to Copenhagen at the invitation of his buddy Niels Bohr, who also has an element named after him, thorium. This is where he and Dirk Koster would eventually discover hafnium. Have you ever wondered why paprika is always labeled Hungarian paprika? Like, how did it get so famous there, and what is it exactly? Well, paprika means pepper, as in, like peppers that originally came from the New World and were brought to Europe like 500 years ago. Remember, European food was terribly bland to a point they decided to like take over the entire world and bring back ingredients that made food actually taste good. At that time in Europe, black pepper was pretty much the spiciest thing you could get, but it was extremely expensive and it didn't actually grow anywhere in Europe. Peppers, they're really called chilies, but Europeans started calling them peppers after the spicy black pepper, as that was the only thing they could relate to it. So all paprika is like pepper, just a pepper, like a bell pepper, that has been cut up, de-seeded, and dried, and crushed into a powder. That's it. Sweet paprika comes from a sweet pepper. Hot paprika comes from a hot pepper. It's that simple. The reason it's big in Hungary, though, is because in some of their many disputes, the Ottoman Empire cut off trade routes to Hungary in the 1700s, and that's where all the black pepper was coming from. So paprika soon took over for black pepper as a replacement for the pepper ingredients there. So now it's April 1920 at the Niels Bohr's Institute of Theoretical Physics. Niels Bohr put it to George to start investigating the missing place on the periodic table, number 72. There had been many attempts at discovering number 72, but all had failed. Actually, before the war, George was meant to go back to England and work with George G.J. Moseley to learn X-ray spectroscopy, but Moseley was killed in action in World War I in Turkey, shot by a sniper. Again, World War I was a stupid war, fought for stupid ideas. So back in Copenhagen, George and Dirk built themselves an X-ray spectroscope starting in 1922, and it was put forward by Niels Bohr that the missing element 72 would be similar to zirconium and part of the titanium group, not the rare earth elements. By the way, it was actually the guy Dirk who actually built the spectroscope while George worked on the chemistry side of things. So once the machine was built, the first thing to do was to get their hands on some zirconium from the geology department, hoping that the missing number 72 would be found in small amounts within. And by blind luck, the method they figured they would just like start out with turned out to be the best possible way of going at things. So first they removed as much of the unwanted material from the zirconium sample they had. Then they analyzed that under a spectroscope, which showed some possible lines of the missing number 72. Then it kind of gets out of my understanding. This is the quote from his biography. He decided to dissolve as much of the sample as possible and to crystallize the double fluorides of zirconium. That basically proved they had number 72. And coincidentally, Niels Bohr was in Stockholm accepting his Nobel Prize when they called him to tell him during his acceptance speech that he was right about missing 72 being found within zirconium. So just a cool course of events. Of course, though, this was not without some controversy. Georges Urbain, who had discovered lutetium and had also attempted to discover 72, yeah, he turned out to be wrong about it in the end, but he wrote this in the journal Nature in 1923. Quote, Koster and Hevesy announced that they have obtained the high-frequency spectrum of the number element atomic 72. This very important result marks a progress in the question we opened. It is only regrettable that Koster and Hevesy tried to discredit our own result. Then later says, quote, had observed arc lines not being attributable to any known element were considered as belonging to a new element, keltium. Keltium was what Urbain wanted to name 72. It's funny because, like, you know, it almost reads like the most polite diss track you've ever heard, but like, you know, they were very serious about this. So Hevesy discovered a new element, and so now he was a very respected scientist and received funding and adoration. He continued working with the X-ray spectroscope, studying radioactive isotopes, and moved back to Freiburg, Germany in 1930, which was a bad time to be in Germany. When the Nazis took power in 1933, it actually took George a few months to realize, like, the Nazis meant what they said as far as their anti-Semitism. And, you know, despite being from Hungary, like, George felt at home in Freiburg. Like, his kids were born there. But George saw the literal writing on the wall and returned to Hungary and then back to Copenhagen to get out of Germany. Actually, his colleagues and students, like, really deeply resented him moving. Like, it just kind of goes to show, like, no one really realized how bad it was going to be for the Jews in Germany. Like, they thought he could stay and it would be okay, but he knew when he got out. So he ended up in Copenhagen with his family. This time, he's a refugee. So the next decade, though, he's in Copenhagen. He continues his work. But yeah, the Nazis invade Poland in 1939. The following year, France, Belgium, Netherlands, Norway, and Denmark. So George and his family actually lived under Nazi occupation for 3 years until 1943, when the Holocaust really started to ramp up. The Nazis really wanted Denmark to give up its Jewish population. It's about like 7,800 people. The Danish people would not do. And so in 1943, they were able to sneak out basically their entire Jewish population over to Sweden, who was neutral at the time. So yeah, this included George, his family, Niels Bohr, who was half Jewish and an anti-fascist. So, you know, good on you, Denmark and Sweden. If you saw Oppenheimer, like this is when Niels Bohr shows up at the Manhattan Project right after he escapes with George and his family. So under Nazi rule though, it was illegal to move gold out of the country, including gold that was on Nobel Prizes. So George quite cleverly came up with the idea to dissolve the Nobel Prizes of James Franck and Max von Laue, these two other German physicists and anti-fascists who also escaped. So George decided to actually dissolve their Nobel Prizes in aqua regia. It was a mixture of nitric acid and hydrochloric acid. So yeah, he outscienced the Nazis, you know, you gotta love that. After the war, George came back to the University of Copenhagen and found the gold that he had dissolved in the aqua regia, and the Nobel Committee gladly cast new metals out of the dissolved gold. By the way, when George was living in Sweden during the war, he received his own Nobel Prize in 1943. And every Nobel Prize recipient gets the option of becoming a Swedish citizen, though most don't actually accept that. George did. So he traded his Hungarian passport for a Swedish one. Years after the war though, George and his family moved back to Freiburg in Germany, which, you know, again, he considered his home. And he died there in 1966. So what an amazing life this guy had. Definitely worth more than just like the 10 paragraphs they have on him on Wikipedia. Okay, so I just got through the story of George de Hevesy, which was honestly more interesting than hafnium itself. Hafnium as an element is still useful in certain industries. Zirconium ore usually has about 5% hafnium found within it. So that's still how it's taken from the earth. They mine zirconium, get hafnium out of it. Actually, zirconium and hafnium, their chemical behaviors are more similar to each other than any other elements on the periodic table. And there's a little bit in the sun. Yep, the hafnium vapors have been found in the sun's atmosphere, which is neat. On Earth today, most hafnium is mined from zirconium minerals found in beach and river sands, especially from Florida, but it's all over the world. It's the 46th most abundant element in Earth's crust, so right there halfway through the elements. So it's not really that rare, which is, you know, interesting because it ends up being one of the last naturally occurring elements to be discovered on Earth. Today, hafnium is mostly used in nuclear control rods and nuclear power plants, including on nuclear-powered submarines. Hafnium does make some metal alloys, especially transition metals like iron, niobium, tantalum, and titanium. And tantalum hafnium carbide metal alloy has a melting degree point of 7,617 degrees Fahrenheit. So that's like 3 times the melting point of carbon steel. So that stuff is pretty useful. It's delicious, yeah. Overall, hafnium is fine. It's cool, you know, it's a cool element. But the story of George de Hevesy escaping the Nazis, discovering an element, living all over Europe, seeing 2 world wars, getting a Nobel Prize, I mean, all of it is just incredible. Honestly though, for this recipe, fantastic. For how simple it is, delicious and cheap. Thank you. See you next time.